Alright y'all, today we are going to talk about stoichiometry. So, stoichiometry is a big word, but it is one of the cornerstones of chemistry. So, in stoichiometry, if you know a chemical reaction, basically if you have just one amount in that chemical reaction, you can calculate any other amount associated with it. It's a really useful tool, and we use it all the time as chemists, and whether you know it or not, the things that you rely on use stoichiometry in order to... Actually, airbags are an excellent example of stoichiometry in everyday life. The typical driver's side airbag fills up, it's about 65 liters of gas in literally milliseconds. And the way that works is you've got a little piece of tech in your car called an accelerometer. And when you smash into something, your car changes its speed so quickly that that accelerometer detects the change in that speed and it connects a circuit. It's kind of like this wire in your toaster. That circuit heats up and it's connected to a sample of sodium azide. That sodium azide then explodes by a simplified equation, which you can see right here. And that sodium azide turns into nitrogen gas. The nitrogen gas is what fills up your airbag. But the question for an airbag manufacturer is how much sodium azide is needed in order to fill a 65-liter space. We know from the chemical reaction that sodium azide turns into sodium metal and nitrogen gas. So that is going to be almost completely filled by the gas, and the amount of volume taken up by the solid sodium is negligible. So we want to know how much sodium azide would be needed to convert into 65 liters of nitrogen gas. This, my friends, is stoichiometry, because you know a value about one substance and you want to know a value about another substance, and you know the chemical reaction. So the first step of stoichiometry is get to moles. The only compound that we have enough information about to get to moles is nitrogen, and that is because it's the only compound that we have any information about at all. So we have 65 liters, and we need to eventually get that to moles. Right now, we're pretty comfortable going from grams to moles. The question is, can we go from liters to grams? And the answer is yes, of course. We just need the density. So because this is a real-world example, you could look up the density of nitrogen gas. I'm going to give it to you because actually density of gases is a bit of a tricky concept, because gases, as we know, are compressible, and so depending on the temperature, the volume of that gas can vary. Now, the temperature in your airbag as it's exploding is about 300 degrees Celsius or 573 Kelvin, and so I'm going to give you the density of nitrogen at 573 Kelvin, which we will learn how to calculate later on, but for now, the density of nitrogen gas is 0.596 grams per liter at the temperature that the airbag is exploding. Okay, so if we have the density, we can get from the volume to the mass, and from the mass we can get to the moles by using the molar mass. So we have 65 liters of nitrogen gas, so we want to cancel out the liters, so we'll put the liters here and the grams here. That 0.596 goes with the grams per 1 liter. Now we have grams of nitrogen, so we want to cancel the grams of nitrogen here, and we want to convert to moles. That's the whole goal of the first step of stoichiometry, is to convert to moles. To convert between grams and moles, we just need the molar mass. The molar mass of nitrogen, because this is diatomic, it will be double what you find on the periodic table. Okay, so we completed our first step. We successfully converted to moles of nitrogen. Step 2 of stoichiometry is go from moles of what you have to moles of what you're interested in. So we have nitrogen, we're interested in sodium azide. We can go from moles of one to moles of the other by using these coefficients that we found in our balanced reaction equation. So the unit that goes on the bottom is moles of nitrogen. The unit that goes on the top is moles of sodium azide. From our balanced equation, we saw that it takes 2 moles of sodium azide to make 3 moles of nitrogen. Step 2, check. Okay, and the last step of stoichiometry is to go from moles of your goal to whatever unit you want. Our question asks how much sodium azide is needed. Because sodium azide is a solid, then probably we want that unit in grams. So let's convert from moles to grams of sodium azide. Put the moles on the bottom because that cancels the moles up here. And to go to grams, all we need is the molar mass. The molar mass of sodium azide is 65.02 grams per mole. So then all we have to do is make sure our units cancel. So let's double check. We canceled the liters, we canceled the grams of nitrogen, we canceled moles of nitrogen, canceled moles of sodium azide, and now we have grams of sodium azide, which answers our question. So if we calculate that all out, we see that we have 59.9 grams of sodium azide. Our first question is, does that make sense? 60 grams, not very much substance, so that makes sense because it's stuffed in a small compartment in your steering wheel. So our answer makes sense, and then the next question is sig figs. So we go back to where we started calculating, which was right here at the beginning. This one has 2, the density has 3, the molar mass of nitrogen we calculated to 4, the molar ratio is exact, and the molar mass again we calculated to 4, which means that our answer we need to round to 2 significant figures. So we can try and round that to 60, but now the problem is that we only have 1, so we need to put this in scientific notation. So we would need 60 grams of sodium azide in order to properly inflate an airbag. And that's it for this edition of Chemistry in Real Life.